Hi guys, it's Mrs. Webb here. I'm coming to you today to talk a little bit about pH indicators, which are used quite commonly in chemistry, specifically when we're working with acids and bases, and specifically when we're doing something called a titration analysis, which we're going to get to in the coming lessons. So what I've done here is I've given you an example of a pH indicator chart. What indicators are, they are either weak acids or weak bases that we will put into a solution. You'll put a drop or two. They generally come in liquid form, so usually you'll put a drop, 2 or 3 drops into a solution, and what will happen when you put that indicator into solution is it'll generally change a color, and what that color indicates to us is the pH range of the solution. So indicators don't tell us a specific pH like a pH probe would. They tell us the range of pH that a solution may have. And these are of particular use when we're doing titration analysis, because we can figure out when we've reached the end point of our titration, as you'll see when we get there. But for now, what we're going to use it for is we're going to use it to try to figure out what the pH range is for different types of solutions. So, for example, if we look at bromophenol blue, if we look at bromophenol blue, you'll see that underneath the title it says 3.0 to 4.6. That right there is the pH range at which bromophenol blue will change colors for you. So if I were to put 2 to 3 drops into a solution of unknown pH, and let's say that that solution has a pH of 1. That solution, if I were to put 2 to 3 drops of bromophenol blue, that solution would turn a yellow color, because that bromophenol blue reacts with the solution and it produces this color. So I don't know yet that my pH is 1. I just know that the pH is somewhere below 3.0. It's 3.0 or below. If I were to put that same solution into a base, let's say something with a pH of 12, so something with a pH over here of 12, that bromophenol blue would turn a blue color. Now that doesn't tell me what the pH of my solution tells me. All it does is it tells me that the pH is somewhere between a pH of 4.6, because that's the upper end of my scale, so pH of 4.6, and it could be anywhere to a pH of 14. So all it tells me is that my solution is somewhere in this range. Okay, so that's what indicators tell me, is the range of the pH, not the exact pH. Now there is a transition point, and so you'll see that the color changes between this 3.0 and this 4.6 pH. So when you're within that pH range, what's going to happen is you're going to get a bit of mixing of colors. And so when yellow and blue mix together, they form green. And so if I'm somewhere within this 3.0 and 4.6 pH, my solution is going to turn this green color. Okay. If, for example, we were looking at methyl red, and let's say I had a solution with a pH of 1, so here's my pH of 1, you'll notice that methyl red would be this red color. Okay. At that transition point between 4.6 and 6.2, I'm going to get a bit of mixing here, and so red and yellow make orange, so my solution is going to turn orange. And anywhere above this 6.2, my solution is going to be yellow. So the way we can use indicators to narrow down that pH range, because it doesn't really help me much, if we go back to my example of my solution that had a pH of 12, it doesn't really help me much to use bromophenol blue, because the pH range is huge, right? So I could have a solution that's somewhere from a weak acid all the way to a very strong base. So this doesn't really help me very much in terms of figuring out what kind of solution I'm dealing with. Okay. And so what generally we'll do is we'll use indicators in combination in order to narrow down the pH ranges. Now you guys, I'm going to give you a couple of examples, but you guys are going to do a lab where you're going to do just that. So you're going to have a series of indicators like these ones: crystal, violet, methyl orange, bromocresol blue, or green, bromophenol blue, phenolphthalein, indigo, carmine. And these pHs go from a color change that is on the acidic side to a color change that is on the basic side. And what we're going to do is we're going to test the color of various solutions. So HCl being one, but we're also going to test sodium hydroxide. Actually, let me bring up, I believe I've got it still here for you. We're going to test, I don't know if you guys can see this. There we go. We're going to test hydrochloric acid, sodium hydroxide, sodium carbonate, and acetate. Okay, and we're going to try to get the pH for these by narrowing down the colors and the pH ranges for each of these indicators. So the way we're going to do that, let me give you an example down here. Sorry, we're being a little bit and I'm just going to pause you guys momentarily here. Okay, so I've got an example for you here. So we've got a student test the solution of unknown pH and obtain the following results. Based on the given observations, what is the pH range for the solution? So typically when we're asking questions about what is the pH range for a solution, you're going to be given several indicators. In this case, our particular student used methyl orange, methyl red, and phenolphthalein. They put a couple of drops into the solution. So they have 3 little spot plates maybe, and they put a few drops of each of the indicators into each of the spot plates. The first spot plate showed the color of the solution went yellow. The second spot plate showed the color of the solution was yellow. And the third spot plate showed that the color of the solution was colorless. So what we need to do is, if you look, and I have up here for you guys, if you look in your data booklet, sorry, we're moving a little bit slow here. If you look in your data booklet, what you're going to find on page 10 is a list of common indicators. Okay, so what we need to know is for each of these solutions, what is the pH range and what are the colors? So for methyl orange changes colors at a pH of 3.2 to 4.4. And the colors that you'll see is at a pH of 3.2 or lower, you're going to see a red color. So the solution is going to turn red. At a pH of 4.4 or higher, you're going to see a yellow. And somewhere here in the middle, we're going to see orange. Okay, so if our pH is somewhere between 3.2 and 4.4, we'll see orange. Now, if you notice here, our solution in this particular example is yellow, which means that we have to be at a pH of 4.4, but we could also be anywhere above that. We could be up to a pH of 14. All we know is that we're at least 4.4, but we're also higher. Okay. So that's the one. Now that, again, just like the example I used previously, doesn't help me too much because that's giving me a pH of anywhere from acidic to strong base. Which doesn't really help me narrow down the what type of solution I'm dealing with. So this particular student tests this solution with methyl red. And if you look at your indicators table in your data booklet, methyl red has a pH range of 4.8 to 6.0. And anywhere 4.8 or lower pH range is going to be red, or sorry, a color is going to be red. So if I have a solution that's 4.8 or lower, I'm going to see a red color. If I've got a pH that is at least 6.0, so if my solution has a pH that's at least 6.0, I'll see yellow. Somewhere within 4.8 and 6.0, I'm going to see orange. And again, what I noticed here in this particular test is that my pH has to be at least 6.0 or higher. So what this is telling me right now is that the 4.4, yeah, this original methyl orange told me that the pH had to be at least 4.4 or higher, but this methyl red just corroborated that it can't be 4.4, because if it was somewhere around 4.4, this particular methyl red would have shown a red color, because anywhere from 4.8 and down to 0, I'm going to see a red color. And what I'm seeing here is that this is yellow, which means that it has to have at least a pH of 6.0 or higher than that. So at this point, what I know is that this methyl red has told me that I can ignore this first result. It can't have a pH of below 4.8, because if it did, I would be seeing a red color on this particular test here. And I'm seeing a yellow color, which means that the pH has to be at least 6.0. Now, again, 6.0 to 14 is a really large pH range, so we use a second test, and we use phenolphthalein. And phenolphthalein has a pH range of 8.2 to 10.0. And if the solution has a pH of 8.2 or lower, we're going to get a colorless solution. So you won't see any change. It'll just remain colorless. If our pH is 10.0 up to 14, we're going to see pink. And then somewhere in between, we're going to see light pink. Now, this particular solution here is telling me that I saw colorless. Okay, so I know that if it's colorless, I have to have a pH that is at 8.2 or lower, anywhere to 0, right? In this case, though, I know that it isn't anything down to 0, because my methyl red told me that the lower end had to be at least 6.0. So essentially what I'm looking for as I'm doing this little diagram here is I'm looking for that spot where I find the lower, the minimum pH, and I find the maximum pH. So for this particular test, my pH range must be between 6.0 and 8.2. Okay, so it's all a process of elimination, and this is what you guys are going to do in the lab in order to figure out the pHs of those solutions. So we'll do some more practice during class time. I put some practice on the worksheets and some readings in the textbook. If you guys have any questions, let me know when you come into class, and I will see you soon. Hope you guys are doing well. Stay safe.